Hello friends, welcome to my channel Explore Physics. We are here with the solution of GRE paper GR0177. We are starting in this video from problem number 51. We have solved up to 50 problem in our previous videos. So in this video we will solve from problem number 51 to 55. The problem 51 is stating that unpolarized light of intensity I naught is incident on series of 3 filters. The axis of the second filter is oriented at 45 degree to that of the first, while the axis of the third is oriented at 90 degree to that of the first filter. What is the intensity of light transmitted through the third filter? We have a series of filters. There are 3 filters, 3 polarizers in the front of a light wave having intensity I naught. So if let first filter is oriented in this position, then second filter is oriented in this position, making 45 degree of angle with the position of first one, and the third filter is oriented in this position, which make angle of 90 degree with the reference to the first filter. Now these 3 filters are oriented in this position. Now let we have a light wave which have intensity I naught have to pass through these filters. What will be the intensity of that light waves when it passes through these filters? The initial intensity is I naught. Let the final intensity after passage is I. We have to find this intensity of that wave. Now we have a law in a polarization known as Malus law, which states that the intensity of the light after a polarizer will be equal to I naught into cos of theta. Theta is the angle of polarizer's position when the light of intensity I naught passes with angle of position of a polarizer is theta, then intensity I, we will get intensity I after that polarizer. Let this equal to I over I naught, this is equal to cos of theta. We have given that for the second polarizer it is 45 degree with respect to the first one. So cos 45 degree, cos of 45 degree, this is equal to 1 divided by 2. So 1 over 2 is the value of cos theta. So I in equal to 1 I naught divided by 2. This will be the intensity of the light wave when it passes through the first polarizer, the one polarizer. Now we have 3 polarizers. Each polarizer will make its intensity half. Now we have 3 polarizer. The second half will be I naught over 4, the third half will be I naught over 8. So the intensity we can say for nth polarizer will be I naught divided by 2 power n. Now we have 3 polarized series of 3 polarizers, so n is equal to 3. This will become n I naught divided by 2 whole power 3. This is equal to I naught over 8. So the intensity of this light will be I naught over 8. It will decrease to its 8 time. I is equal to I naught over 8 when it will pass through the series of 3 polarizers oriented in this position. So part B is our right option. Next problem 52. The conventional unit cell of a body centered cubic previous lattice is in figure. The conventional cell has volume A cube. What is the volume of the primitive cell? We have a body centered cubic cell here, and it is given that its volume is A cube. We have to find the primitive unit cell volume. Primitive unit cell volume, this is equal to V over number of atom. V over number of atom. V is the total volume of this primitive unit cell, which is given that V is A cube. We have to find number of atom in this cubic body centered cube. One atom is its center, and there are 8 atom at 8 corner, but each atom contribute its 8 part. Its 8 part to at each corner. So if there are 8 atom and on the corners, and each one contribute its 8th part, then there will be 1 atom total in the corners, and 1 atom is there in the center. So total number of atoms are 2. So this will become A cube divided by 2. So the primitive cell volume will be A cube by 2. Total volume was given A cube, and 2 are the number of atoms in body centered cube. So primitive cell volume, this is equal to V divided by number of atoms. V is the total volume of the cube, and number of atoms are 2. So the primitive cell volume will be A cube by 3. So our part C is right option. Next problem, 53 problem is, which of the following best represent the temperature dependence of resistivity of undoped semiconductor? To answer this question, we should know that there are 3 types of materials: conductor, semiconductor and insulators. Semiconductor is N between conductor and insulators. At room temperature or below room temperatures, the electrons of semiconductor are bound to atoms, but if we increase the temperature, the electron become loose from atoms, so it will responsible for the conduction of electricity. So if we increase the temperature of a semiconductor, it goes toward the conductors, its property goes toward the conductor. So resistivity of the semiconductor decreases if we increase the temperature, and conductivity increases if we increase the temperature. So in increasing temperature, the resistivity will decreases, and with decreasing temperature, the resistivity will increases. So part B is will best represent this relation between resistivity and temperature. Part B is our right option. For conductivity of a semiconductor, if we put here conductivity, if we assume this is conductivity, then part A will be right option for the conductivity, and for resistivity part B is right option. The plot in part B best represent this relation. Next problem is 54. The figure shows a plot of time dependent force Fx of t acting on a particle in motion along x-axis. What is the total impulse delivered to the particle? We have a plot given that a particle, a force of Fx acting on a particle for time t. We have to find the total impulse. The impulse formula for impulse, this is given by Fx del t, the product of force and time. We can see from graph that we have time on x-axis and force on y-axis, so their product is equal to impulse. We can also see that the product of x-axis and y-axis will give us total area under the curve. So the area under the curve will be equal to impulse acting on the particle, or impulse delivered to the particle in time t seconds. So the total time for impulse is 2 seconds, and the total force, maximum force acting on the particle is also 2. Now to find area of this graph, we split it into two equal parts. There become two right angle triangle. So we will find the area of these two right angle triangle. This will be equal to impulse. The area of right angle triangle is half of the product of base multiplied by perpendicular. If we have two triangles, so we can multiply this by 2 because the two triangles are same. The base of these two triangles, this is 1 and this is also 2 minus 1, 1, and the perpendicular for these two triangles is equal to 2. So this will become 2 multiplied by 1 by 2 multiplied by 1 multiplied by 2, this will become the total product will become 2. So this will be 2 kg meter per second. So the impulse delivered to this particle and time t with force Fx will be equal to 2 kg meter per second. So option C is our right option. Problem is 55. A particle of mass m is moving along x-axis with speed v. When it collides with a particle of mass 2m initially at rest, after the collision the first particle has come to rest and the second particle has split into two equal mass pieces that moves at equal angle theta greater than 0 with x-axis as in figure. Which of the following statement correctly describe the speed of two particles? We have a problem that two masses m and 2m. M is moving with speed v while this one is at rest, so its speed is 0. When it collides with it after the collision, before collision it is moving with speed v and this is at rest, and after collision this mass become at rest and this split into two equal parts which moves in this direction with an angle theta. These two split pieces make same angle with x-axis, so we have to find the velocity, the speed of these two split pieces. Now as the particle split into two pieces, so the energy is not conserved in this system but momentum is conserved in every case. So we have to see the momentum conservation. So because after splitting the particle it moves with some angle, making some angle with x-axis, so there will be two components of momentums, x component and y component. We will split these the momentum of these two masses m and two components. So these are the y components of the momentum for mass m, and this is y component for this mass, and this is the x component of momentum. We can see that the x component of both the momentum will add up, but the y component of both the momentum will cancel out each other. So the momentum in horizontal direction will become horizontal momentum and horizontal direction. In horizontal direction before collision, momentum is mv plus this is at rest, so 0 equal to this is theta and this is the perpendicular. So this is a right angle triangle base and perpendicular, this is hypotenuse. So if its velocity is v prime after splitting and this is also v prime, then mv prime cos theta equal to momentum in x direction. This is momentum mv prime in this direction, this is a theta, so this will be mv prime cos theta, mv prime cos theta for this one, and also for this one mv prime cos of theta. So this will add up, this will become mv this equal to mv prime cos of theta to mv prime cos of theta. So m will cancel out with m and v prime will become v divided by cos of 2 cos of theta. So this will be the new velocity of the split pieces, mv prime this equal to v over 2 cos of theta. This is our first equation when we are taking the momentum in horizontal direction. If we take the momentum in vertical direction, there is no momentum before collision in vertical direction because the particle is moving in x-axis. So the before collision in vertical direction momentum is 0, but also we can see that these two particles are moving with same angle, making same angle with x-axis, and these two particles also have same masses and also have same velocities. So the momentum in y direction upward and downward will also be same. We can write that mv prime sine of theta this equal to minus mv prime sine of theta, because we can see here that the momentums in vertical direction are opposite in direction, so we put here a negative sign, minus sign, so 0 equal to mv prime sine of theta equal to mv prime sine minus v prime sine of theta. So these two momentums are in opposite direction but same in magnitude, so there is no momentum before and after collision in vertical direction, but in horizontal direction there is a momentum mv this equal to mv prime cos of theta. So we are taking out v prime of this formula, this is equal to v prime equal to v over 2 cos theta. Now we are coming to the options given. We have to pick the correct option. Now there is also a condition given in the problem that theta is greater than 0, so theta will be equal to 0 or greater than 0. So if it is equal to 0, then cos of theta this is equal to 1. Cos of theta, if cos of theta equal to 1, let me assume the theta is 0, so cos of theta equal to 1, so v prime this will be equal to half of the v, means the v prime, the new velocity of the split pieces will be half of the initial velocity of mass m if there is no angle, if theta is 0, but we have that theta is greater than 0, so increasing theta v prime will decreasing, so v prime will get maximum of v over 2 speed. So the maximum speed of the split pieces will be v over 2, but we have given that theta is greater than 0, so this can never be equal, so this will always be greater than. So if theta is greater than 0, so this term will always less than 1. If cos theta is less than 1, then v prime will always be greater than v by 2. So v prime is the velocity of each particle split pieces after collision, and this value should be always greater than v by 2. So the first option is each moves with speed v, this is wrong. One moves with speed v and other is less than v, wrong. Each moves with speed v by 2, this is wrong. This is correct if theta is equal to 0, so we have theta greater than 0, this is wrong. One moves with v by 2 and other with greater than v by 2, this is also wrong. So each moves with speed greater than v by 2, this is our right option. So part E is option E is our right option. This is the last problem of this video. Please like, share and subscribe.